Hey guys, welcome back to another lesson. Today we're going to talk about composition of functions. This will be a two-part video. The first part would just be kind of just the basics and defining some things, and then what is a composite function. Tomorrow we're going to continue just some more practice with some examples with it, do like a word problem just to kind of see where the application of a composite function can be. There's actually a lot of applications when it does come to composite functions. In fact, you made some calculations yourself throughout the year and just in your own life that deals with composite functions. You just never knew that. Imagine that, right? So let's just go ahead. What I have listed for us right now are the basic operations with two functions. So for the first part, we could either add or subtract two functions together, okay? And when we do that, we can condense the notation. So I did a little plus or minus, but individually, you could say plus or minus. So these could be two separate statements. So f plus g of x, in fact, let me write that down of how it's read. Just right here. All right, the f, we'll just say f, I guess you could say plus g of x, okay? Whatever x is, or the variable, if it is x at that point in time. But f plus g of x, all right, or f minus g of x, you could say. So I can evaluate each one individually, add them together, and then get the result. But this is what it would look like if I combine the notations together. Multiplication, same thing. If I multiply two functions together, there's the variable I put on the outside. That's the same thing as me multiplying them individually. Just be careful. Do not make this an open circle, and you'll see why soon. If you're using multiplication, make sure that's a closed circle. All right, very important. And then for the last one, we have division. A division of two functions can be written this way, but it's the same thing as writing them individually. Now, we do have to be careful with this. At the very bottom, if we talk about domains for a second, remember, domains are all the possible x values that you could put into a function. Now, when it comes to division, we don't want a 0 in the denominator, right? So if you look at function g, you say, okay, here is the function, but I want to make sure it doesn't come out to be 0 because then this doesn't become defined at all. So our domain would be all x values except any x value that makes g of x equal to 0. You're not allowed, equals 0, okay? We're not allowed to have anything that makes it 0 at the very bottom. So there's some domain issues when it comes to division. All right, so there's the basic operations when it comes to two functions. Could we add more than just two functions? Absolutely. If I added three functions, it would be f plus g plus h. And let's say the variable was p this time, okay? So that variable goes for all three of those functions. And you can add four functions, 5. You can keep going with it. All right, sound good? So far, so good? All right, let's look at the very bottom here. So here's an example. And I want to figure out what f times g of x is, given that these two functions are as follows. Okay, so bringing this down, that's the same thing as me multiplying these individually. Okay, so let's go ahead and do that. Function f would be 3x squared minus 2x plus 1 times g of x, which would be x minus 4 for that guy. So go ahead, distribute everything that's in this trinomial to the binomial. It does come out to be a little bit, but let's see, a little bit of a lot of terms. We have 3x cubed minus 12x squared minus 2x squared plus 8x. I can't talk, I'm so sorry. Plus x minus 4. Combine some like terms, we would get 3x cubed minus 14x squared plus 9x minus 4 is my answer. This guy right here, this polynomial, is what it would be if I multiply those two guys together. Okay, so this equation right here represents this guy right there. Okay? Not too bad, right? Now, can we talk about domain and ranges with that? Absolutely. The domain of this guy would be all real numbers. There's not a value that I'm not allowed to plug into it. My range, because it's a cubic function, My range would be, well, all real numbers as well. Okay, it's going to extend infinitely up and down. Remember, it's an odd degree polynomial, so the end behaviors would be in opposite directions. So domain and range for this guy would be all real numbers. Okay, so far so good. Let's do a division one. Adding and subtracting, I didn't do an example like that. It's in my notes, but I kind of figured you guys would be okay adding two equations together and subtracting. I think we're okay when it comes to that stuff. All right, now let's look at division. So I want to figure out what f divided by g of x would be, given that those are the two functions. So this is the same thing as me taking them individually and dividing them. Remember, this is all notation. You just have to know what it means. The operation itself isn't too bad. So we have 3x squared minus 2x plus 1 divided by x minus 4. Now, let's think about the range. I'd like to get to that point, to be honest with you. I don't think we're going to get to it this year, just with COVID and everything. It's been rough trying to get a lot of these lessons through, but range we'll leave off. But for domain, would be what? All real numbers. I can't write. All real numbers except x cannot be, just have enough space. X cannot be 4, right? 4 is not a valid solution to this guy because when I put 4 into here, I get 0 at the bottom, undefined. Now, just to give you a for instance here, okay? Whatever number, and this would be for like your next year math class, any number that's not part of your domain ends up becoming a vertical line. Right here at 4, my function cannot cross right here. It'll do weird things, like it'll come real close to it, and then it'll just kind of ride along with it, just goes all the way up like that. Or if I go in the opposite direction, it'll just come down this way, it won't cross that line. And the reason why it won't cross that line is because, well, primarily, looking at this guy, I cannot have 4 in my equation. Okay, there's no y value for that guy, so my graph should not cross here at all. Okay, now, is this? No. Okay, this is just an example of what the graph could look like when you do have this. We call this an asymptote. Anytime there's a restriction in your domain, it becomes a vertical line, and on the graph, we call it an asymptote. Okay? So far, so good. All right. So this is kind of cool. I mean, we have some functions. We could do some basic operations with them. All right. A lot of pluses there. And we kind of did that already at the beginning of the year. Now let's change things up a little bit. Okay. Let's combine them differently. Okay. So let's look at this. This is an actual composition. What we did previously was just basic operations. This is a composition. Now, this guy right here, there's an open circle here, which indicates that this is a composition, all right? This is not fog. A lot of people like saying that, hey, it's fog of x. No, it's not. Okay, this would be f of g of x. That's how you would actually pronounce it, f of g of x, okay? And what it means, I'm going to take whatever the first value is here, or the first function is here, g. I'm going to take the entire function and plug it into function f. That's what I'm going to do, okay? And then I'm going to evaluate what function f is. Remember those like Russian dolls? You know, there's a smaller doll inside of a larger doll inside of another larger doll, and it keeps going. This is kind of the same thing. Or if you got pranked before, did you ever have a package wrapped up and you open the packaging, you open the wrapping, and you see another box? You take that out, you unwrap it, you go through the same process, you find another box, and you just keep going. Kind of like the same thing, okay? Now, here's the deal. And what I'm writing here is pretty important. It's honestly, it makes sense when you do a couple problems. You're like, oh yeah, this is what's actually happening. And we are going to do some examples to where this will help you. This is defined if, and only if, that's what the double F stands for, the range of g of x is a subset of the domain of f of x. And this picture right here describes it. So we start with our domain, that's in g of x, right? All the x values that I'm allowed to plug into here. Then I plug it into g, and I get all the outputs of g of x, which is your range for just this function. Now, all the outputs for g of x will then be used to be plugged into f. So this is the range of g of x being plugged into here. Okay? And then the output would be the entire thing. Let's do an example to kind of put some concrete to this idea, all right? Because it is kind of weird right now. Let's do this. I don't want to erase that. I'm going to come back to that. All right. So let's try an example out. And what I'm going to do is we're just going to do a set of order pairs. Okay, we're not going to do quite an equation yet. Let's just do an order pair. So f of x is all of these pairs. So 2, 6, 9, 4, 7, 7, 0, -1. G of x is 7, 0, -1, 7, 4, 9, 8, 2. Find f of g of x. Okay, that's what we're going to do. Okay, and what we're going to do is when we're done finding this, we're going to make a comparison back to what we just did for definition. Okay, so remember, this is the same thing as me taking g of x's values and plugging into f. Okay, we always work from the inside out. So what I'm going to do is I'm going to pick a number that's in g. Okay, a domain value. Remember, domain means x values. I'm going to pick 7. 7 is an x value that's in this guy right here. Now, I'll tell you what, let me just let me zoom in. That way it's a little bit easier to see. Sorry. Okay, so I'm going to pick 7. Okay. Now, if I plug 7 into function g, what's the output going to be? Well, take a look. If I plug 7 in, my output's going to be 0. That's the y value. Okay. Now I'm going to plug 0 into function f. So here's function f. Where do I see 0 at? Here. And if I plug 0 in, what's my output? -1. Okay. Now, let me write this separately. If I did this, the answer would be -1 without that intermediate step. Does that make sense? Okay. Let's continue. Let's do it for every x value that's in g of x. Okay, so here we go. Oops. Let's plug in -1. And let's see if I plug -1 in, what would the entire thing equal? Okay, if I plug -1 into function g, here's function g. If I plug -1 in, the output's 7. Okay. So that tells me I'm going to plug 7 into function f. You always evaluate from the inside out. Okay, so you solve what this is in parentheses first, and then whatever this answer is, you plug it into what's on the outside. If I plug 7 into function f, notice the output is, ironically, 7. It didn't change. Let's continue. Let's try 4. And I highly encourage you to pause the video to do the last two, see if you get the right answers. If I plug 4 in, my output for g is 9. Now let's go to function f. If I plug 9 in, I get 4 for that guy. And the final value, okay, I'm going to plug 8 into function g. So here's 8. If I plug it in, the output's 2. And if I plug 2 into f of x, my output's going to be 6 for that guy. Now, what are all my answers? What's my domain and my range? Well, we're going to leave it as an ordered pair. So this is going to be what? If I plug 7 in, the answer was -1. If I plug in -1, the answer was 7. Plug in 4, I got 4. Plug in 8, I got 6. there's my answer. Just like that. Okay. Now let's go back. Let's make a parallel little comparison here. Okay. Can I put both of these together? I might have to move the camera back. You're too close to the board. Step back, guys. You're crowding the board. Okay. There we go. That's a little better. Now let's make a inference. All of the range values. Okay, all the range values for this guy, for G, became the input values for F, right? That's what we discovered. Now look back at this guy over here. The outputs for G became the domain of F. Yeah, it did, right? Remember, domain is what are your input values? My input values that I plugged in for F was what came of G. All right, so see how this describes the calculation over here. And it also describes what the actual concept is in words, all right? The English part of it, sorry. For some reason, I can't English well today. I apologize. So if the range of G of X is a subset of the domain of F of X, what would happen if one of the range values doesn't work for this guy? What would happen? Okay. I'll show you. And then this will be it for part 1. All right. We'll do part 2 tomorrow. So, what's this all mean? Well, let's take a look at this. Let's say, let me change this to a 2. Or no, let's change it to an 8. Okay? Watch what happens. So if I were to, we're going to look at this guy here. If I plug -1 in, I get 7. If I plug 7 in, there's nothing there. Okay? That means it's undefined. Okay? Undefined. If one of the inputs does not give me an output here when I'm going through this process, it's just undefined at that point. Now, what does that mean graphically? Well, if I had a line that I was graphing like this, but one of the values didn't work, remember when we did piecewise functions? We would put an open circle there, indicating that that x value is not in the domain. It doesn't exist. And that can happen, okay? Let me go back to the division. It's nice when you have all these whiteboards. Let me go back to the division problem here, okay? What value does not work for this guy? It's very similar to this. There's a thing in the domain that doesn't work for the entire function. Just means that on the graph, you'll see an open circle there, okay? Or if you're graphing something like a rational function here, or a rational two functions here, I guess you could say, you'll have like one of those asymptotes being graphed with it, which, I erased. Darn it, I erased that graph. But anyway, that's what it would be for that guy, okay? What do you think? So far, so good, okay? Part 2 would be coming later on, okay? Possibly tomorrow. I'll get that uploaded for you. But this is just the basics, okay? Adding, subtracting, multiplying, dividing by functions, and just with division, we got to be careful about the domain. And then what is a composite function, which we just did, and what does that mean in terms of domain and range? Okay? So, hope you're all doing well, and until next time, I will see you in the next lesson video. Take care.